Hello all, myself Bharat MS. This is chapter number 1, Introduction to Scanning Electron Microscope. The objective of this chapter is to introduce to scanning electron microscope or the technique scanning electron microscopy, which is usually abbreviated as SEM. Scanning electron microscope is a device that uses focused beam of high energy electrons to generate a wide variety of signals at the surface of samples. So few key points: focused beam of high energy electrons to generate various signals. So the electrons that are used are focused onto the sample and they are of high energy. They produce different types of signals, and the signals that are generated due to the electron sample interaction give information about the surface morphology, which is basically information about the sample surface, chemical composition, chemical makeup of the samples, crystalline structure of the samples that include crystallinity or any other crystal related information, orientation of the materials present inside the samples such as orientation of fabrics, orientation of crystals, and so on. So in this figure 1, we can see a typical we can see how a typical SEM looks like. What is shown here is a Geol 6060, a particular model of an SEM, which consists of various components for various purposes, which will not get into the details of it. Basically, a Geol 6060 SEM is a thermionic low pressure or variable pressure SEM. Again, we'll see what these terminologies mean in the subsequent chapters. So a typical SEM consists of an electron optical column. So what we see here in the form of a long tube is an electron optical column, which consists of electromagnetic lenses, magnets, an electron gun to produce electrons, and various other components. And there are various hardware components such as knobs. We can see here there are so many knobs to work with. There is a chamber door. The place where we place the sample is the chamber, and this is the door for that chamber. And there can be so many detectors depending on what signals we want to detect. So basically what is shown here is an SC detector, which is a secondary electron detector, and there is liquid nitrogen tank for EDS analysis. Energy dispersive spectroscopy, we'll see again what it is in the later chapters. So this is how a typical SEM looks like, and the schematic of a similar SEM is shown in figure 2, where we can see the skeleton or the makeup of the SEM, which has a filament or an electron gun to produce electrons. There is something called Venelt cylinder, there is an anode, and so many other parts. Again, we'll not get into the details of it as of now. So what is seen here can be typically divided into 3 groups of components. One is an electron optical column, which we saw in the form of a long tube here, and there is a vacuum system that is needed. Since we are dealing with electrons, we have to have vacuum. We cannot use air, because if we use air, the electrons will ionize the air. So what we need is a vacuum system. So it's a system. So we need something to produce vacuum. We need a setup to maintain the vacuum. We need arrangements to measure the vacuum and so on. And finally, the final component is for detecting various types of signals that are generated, and to display them onto a computer screen or any typical screen, so that we can see the result and understand or interpret the results that we get about the samples. The signals that are generated there are wide variety of signals that are generated, that include imaging signals, basically the image signals that are used to construct an image of the sample. There are characteristic signals which can provide information about the chemical composition, about the oxide composition of the samples. And there are other types of signals that include phonon plasmon excitation, Bremsstrahlung, specimen current, and so on. So there are wide variety of signals that are generated for various purposes, which we'll see later. And out of all these signals that are mentioned in the table here, only the backscattered electron signals are due to elastic scattering, and rest of all the signals are due to inelastic scattering. So basically there is something called elastic scattering and there is something called inelastic scattering. So we'll see again what these terminologies mean in the next chapters. So finally, coming to the reference that I'll be using for my tutorials, this is a very good book out there by Goldstein called Scanning Electron Microscopy and X-ray Microanalysis, which provide in-depth or detailed information about SEM technique. So to summarize, in this chapter, we have seen what a typical SEM looks like, and the typical makeup or the skeleton of an SEM, and what are the three major groups of components of a typical SEM, and typical signals that are generated, which provide various information about the samples under study. Thank you for listening.